I'm going to explain about 3 to 8 decoder. If you want to get my future videos, subscribe my channel. Coming to the decoder, n input lines are converted into 2 power n output lines is called as decoder. So for example, if you take n value is 3, that is 3 inputs to 2 power 3 means that is 8 lines, that is 3 to 8 decoder. 3 inputs are converted into 8 output lines. And coming to the one more definition, so decoder means it converts that is encoded form data into original form, that is the decoder. I'll tell you one example. So here I have a message, that is original message, that is 1010 1001 is there. So this is my original data. So this original data is encoded into, for example, 10. For security reason or any other reasons, this original data I have converted into that is 10. So this is an encoded form. This is an encoder. So this is an encoded form. So this after encoding form, I want that is my original data. So need to decode here. So again 10 is decoded into original data, that is 1001. So this is an decoding form. So this is an decoded data. This is an decoder. So that is the original meaning for decoder. So one form is converted into another form is encoded, and another form is again that is converted into original form is decoded into original form is called as decoder. Coming to the 3 to 8 decoder, so there are 3 inputs are there, 3 inputs, and that is 8 output lines are there. So 1, 2, 3, we can assume anything, either D0, D1, D2, D3, D4, D4 like this, D4, D5, D6, D7 till D7. So D7 means D0 to D7 means 8 output lines. We can assume anything here, A1, A2, A3, or else Y1, Y2, Y3. We can assume anything. So I'll tell you here, I'll show you. So there, here we can say this n input lines are converted into 2 power n output lines. So here you can say this the same thing. This is an decoder block diagram. So here this is an logic diagram, and this is an that is truth table. I will tell you how to decode. So there are 3 inputs are there. 3 inputs, we can assume anything here. I am assuming the inputs are that is x, y, z. X, y, z are the inputs. So I have a data that is 0, 0, 0. So this is the binary equivalence also, it is 0. So I am assuming this is D0, output is D0, binary output is 0. I am assuming this should be selected, this should be high. So and remaining 7 data inputs are 0. D1 is 1, D1 is 0, D2 is 0, and D3 is 0, and D4 is 0, and D5 is 0, D5 is 0, and D6 and D7. So these all are zeros, when you are giving 0, 0, 0. So these are the input lines, and these are the output data. So when you are giving 0, 0, 1, for example 0, 0, 1, so here I am assuming 1 means this should be, that is D1 should be activate, and remaining all should be zeros. This is one more decoded data. And again I am assuming 0, 1, 0. So means it is binary equivalent is 0, 1, 0 binary. Decimal equivalent is 2. So when in this case the second position 2 should be activate, and remaining should be zeros. So this is 0, 0, 0, 0. And similarly, so when it is 0, 1, 1 means it is 3. The decimal equivalent for 0, 1, 1 is 3. So in this case, the third D3 should be activate, and remaining all should be equal to zeros. All should be equal to zeros, 0, 0. And again 1, 0, 0 means it is the decimal equivalent for this is 4. Then fourth position should be activate, and remaining all should be equal to 0. Fourth should be 1, and remaining are all are zeros. And the next 101. 101 means it is 5. Decimal equivalent is 5. So then in this case 5 should be high and remaining all should be equal to zeros. Similarly, 110 means it is 6. So sixth position should be high and remaining all should be equal to 0, 0, 0, 0. And again last one, that is 111 means it is 7. So this that is 8. So this should be equal to D7 position should be high, that is 8th, that is 5, 6, 7th position should be high and remaining should be equal to 0, 0, 0, 0. So this is that about truth table. You can say this for logic diagram. When if you want D0, so when it is D0 is high, X bar, Y bar, Z bar, because all are zeros. When the input is D1 is high at X bar, 0, 0 means Y bar and 1 means Z. So again when the input is high here, so when it is 0 means X bar, 1 means Y and Z means 0, Y Z bar. So X, Y, Z bar. So like that we need to draw the truth table, logic diagram. I'm going with the logic diagram. So D0, D1, D1, D2, D2, D3, D4, D4, D5, D6, D7, D7. We know that D0 equal to, you can say this 0, 0, D0 is high at 0, 0, 0. So means 0, 0, 0 means X bar, Y bar, Z bar. And D1 is high at D1 is high at X bar, Y bar 1. 1 means Z. X bar, Y bar, Z. 1 means Z. And similarly, this is D2 is high at 1, 0, 1, 0. 0, 1, 0 means 0 means X bar, 1 means Y, Z bar. And coming to the this D3. Coming to the D3 you can see this 0, 1, 1. 0, 1, 1 means 0, 1, 1. 0, 1, 1 means X bar, 1, 1 means Y and Z. Similarly, we can go with that is D4 means 1, 0, 0. 1, 0, 0 means X, Y bar, Z bar. And we can see this D5. D5 means D5 is high at 101. D5 is high. D5 is high at D5 is high at 101. 101. 101 means X, 0 means Y bar and 1 means Z. So we can write like that 110. Next one is 110 means X, Y, Z bar. And last one we can say this all are ones. In that case this is high. So here you can say this high at 111. So means we can say this X, Y, Z. So we can draw easily now the logic diagram. So assume this is X, Y and Z. So I am assuming this is X and this is Y and this is Z and this is X bar and this is Y bar and this is Z bar, I am assuming Z bar. So all are there. We can easily draw the circuit. So D0 means D0. We can say this D0 means X bar, Y bar, Z bar. X bar, Y bar and Z bar. I will draw it here. X bar, Y bar, Z bar. So this is D0. X bar, Y bar and Z bar. This is D0. And similarly D1 you can say this D1 means X bar, Y bar, Z bar. X bar means this one X bar and this is Y bar. We can see this Y bar and Z means this one is Z And similarly D2, we can say this D2 means X bar, this is X bar, X bar, and this is Y, and the third one is Z bar. So like this we can draw easily the logic diagram. But finally the decoder means these three inputs are converted, decoded into, that is 8 output lines data. And we can say this here also same thing. This is an decoder block diagram, and this is an decoder truth table. So there are three input lines are converted into, we can draw it, we can take the d0 from this side to this side, and or else this side to this side, anyway both the ways we can take. And by using this we can draw this logic diagram easily. So this is about decoder. If you have any doubts you can send to me. Thank you.